So the way the internship would majorly work is one, you would have to do some tasks that you'll be given, and also you would have to do some self-learning. Like there are some extra skills that would emphasize that you pay attention to, like how do you write a comprehensive report, how do you create slide deck, how do you communicate such a way that everyone understands, what are some workplace etiquette. Like we are going to really focus on those things that are outside pandas, like that are outside the technical skills like Excel, Python, SQL, Power BI. We are going to have like a lot of focus, and also we would pay attention to in terms of your technical skills to the parts that you really have more, like maybe should I say your weak part. We'll look at it like the parts that are weak, and we'll try to help you build help you build his strength too. Maybe by taking, yeah, it could be either free courses or it could be paid courses that we're going to obviously get for you. So that at least by the time you finish the internship, you'll be able to claim significant experience and nobody's going to raise their brows that, oh, you don't look like somebody that has 1 year experience or something. So that's the plan. So you just basically you'll be paid to learn. That's what the plan is all about. So we started Matplotlib last week, and I mentioned that Matplotlib is. Before I go on, is have you started your project, and do you have any difficulty yet? Yes, Tafik.
Yeah, I've started. So I'm left with this GUI, this thing that I said we should include. I don't know the one we should use. Is it because the one I tried is I think Twinkle or something.
Tinker.
Yeah, exactly. But I didn't really get it. So
Okay.
I don't know, maybe it's
How do
TMS or
I
space.
how do I no, like in the what's it called? You see that I mentioned specifically that it is optional.
Okay.
Like it's just for you to get, like it's just for people who are willing to go above and beyond. So if you feel like you're struggling with it, it's not inside our curriculum to learn Tinker. Do you get what I'm trying to say? Or learn other GUI interface. Like there is Streamlit. Streamlit is actually way easier than Tinker. But then if you want me to get you a tutorial that can help you with Tinker, I'm more than willing to provide it. It's just for people who are willing to go above and beyond. You see, it's very minute. It's just extra 5% that you get, but then it's really going to show a lot for you. Like if you can go ahead and find a way to get it done. But then it's, you see in front of it, it's optional.
Okay. Oh, I'll be glad you can share the.
Yes, please just remind me on WhatsApp. I'll share you a tutorial on how to use Tinker. Because
Thank you.
the truth is, the whole boot camp is just to give you guys, how do I put it now? The whole boot camp is not to teach you guys to become an expert. It's just to give you guys like a solid foundation, or should I say a foundation, not necessarily so solid, in such a way that you know what you need and you can start picking them up and do self-learning. Like just imagine the way, if even if you get a job today, in 4 or 5 years you still want to be practicing, and quite a whole lot of new things would have come out, right? And
Yes.
you have to learn them yourself. But the fact that you already have the background, you already have like the exposure to it, it's going to help you to do self-learning. This approach that I told you guys to use to learn is actually the way I personally do when I want to learn a new concept. Like I divide it, say for instance now, it's maybe like a 10-hour video. I can decide to divide it into 30. Do you get what I'm trying to say? So it's just going to be like 20 minutes per day. if because 10 hours is going to be 600 minutes, so it's going to be like for 30 days, it's going to be like 20 minutes per day. And I make sure that every day I try to have like 2 points that interest me and 2 points that need clarification. And sometimes any additional comments, I try to put additional comments too. Like additional comments are usually maybe, for instance, now I'm learning pandas and I don't know Python. Do you know what I'm trying to? So I can try to say, okay, I'm learning this concept, but it seems like the guy made a reference to a prerequisite. I think I should focus on that or I should watch that too. So I just put it as additional comment under it. So it's going to really, really help you because it's a different thing to just watch a video and think you know it, but to sit down and take notes of what you learned and what you didn't understand well. It's a different ballgame and it helps your understanding. So, like I was trying to say, you guys would really, really have to do a lot of self-learning yourself, either here or when you get a job or any company. Like you are going to learn new skills. It doesn't have to be necessarily technical. It doesn't have to be necessarily a technical skill. It's just something that you are going to do. I remember there was a time I had to work on a project and it required React. I've not used any. I've not even used. Then I had not used JavaScript before in my life. Not to talk of using JavaScript framework. It's just like somebody that has never used Python before now trying to use pandas. Like there's going to be a gap, and I had to deliver the project. I can't go back to my boss and say, "I'm sorry, I can't do it." I just had to find a way to crash learn and quickly put out the project. I don't know if that makes sense.
Yes,
So
sir.
along the line when you start working, you are going to encounter so many scenarios like that. They are going to even it could be when you are doing interview, they are going to give you take home assignments that is way outside of what we've done. Like it could be even geopandas. When we say geopandas, we are talking about analyzing data that has to do with coordinate, that has to do with location. There are some companies that basically they focus on stuff like that. You could work with it could be that you work with an healthcare company and majorly what they focus on would be more like health data, and the way you deal with financial data will be different from the way you would deal with health data. In fact, at my place of work, we we really plot our charts using all of these pandas, sorry, Python, using Power BI, Excel. There is an app that we normally use. Sorry, there is a platform that we normally use. We call it Flourish. Let me show you. We call the app Flourish. Like it's an AI powered. Can you see my new screen?
Yes, sir.
So it's more of an AI powered. What's it called? Obviously, it's paid, but then like you can do things that are way more interesting here, and it's even no code, meaning that you don't necessarily have to write code. And when you join the company, obviously give you resources to learn this, and you have to become like proficient at it and be able to create this kind of interesting slides. So what I'm trying to bring out for you is that life goes beyond just focusing on learning what they are teaching you. It's way much more important for you to learn how to build yourself. So that's why some of these things, like I know that the assignment I gave you, the project I gave you, is beyond. If I want to use your current capacity to judge, it's quite beyond your current capacity, right? But then you're not going to grow by doing things that are in your current capacity. There is no way you're going to grow. It is when you get outside of your comfort zone, that's when you will be able to grow. So we started, let's go back to Matplotlib. We started Matplotlib last week, and I specifically mentioned that Matplotlib is used for something. Who can remind me? Hello.
Visualization, sir.
Yeah, visualization. But why, please, can you help us to record? Thank you. Please help us to upload it on YouTube and share the link on the class page, like on the platforms for those that are not able to join. So we normally use it for visualization. Like I mentioned last week also, the week before that, Pandas is more like the Excel version of Python, right? While Matplotlib is the part where, the part where you make your visualization, where you create all of your interesting charts. And I've showed us how to create a couple of charts, right? Like I've showed us how to create a line plot, if I'm not mistaken. I've shown us how to create what other kind of charts did we talk about? People that were here last week.
Bar charts.
Yeah, we created bar charts. What else again? Line charts. Line charts is what I've mentioned earlier, right? I mentioned line charts. So we created line charts. We created what kind of chart is this? Yes, scattered plot. What about this? What kind of chart is this? Is this vertical or horizontal? Okay. What about this? Which one is this? Histogram. When do we use? What's the difference between bar chart and histogram? What's the difference between bar chart and histogram? They look similar.
Histogram usually works with ranges.
Well, with ranges, like what do you mean by
Like
ranges?
ranges of numbers. When we plot the graph, it should be between ranges of numbers. While bar charts, we have particular values, specific values.
Okay, just to help you refine what you have said, we normally use bar charts for categorical variables. Do you know what I'm trying to say? And we normally use histogram. We use majorly histogram for continuous variable like numbers, like do you get what I'm trying to say? So that's the major difference between them. Khan Academy statistics. I want to look. Okay, yes, it's even the first side. So this is bar graphs. So like this is one of the reasons that I was emphasizing that you guys make sure that you go through the statistics. This is bar graphs. This is how to read it. This is how you create one. Can you see? This is entirely on bar charts alone. Like that's one like the first thing that was expected of you guys. And I'm sure that year two we are going to have things that are related to histogram here. Can you see histogram? So that's why I was emphasizing that you guys should go through this because it's going to really help you. You see all those IQR that I was mentioning, they are all here. Like I think I saw see all of these percentile, interquartile range, density curves. So I think we stopped. This is where we stopped for the basic chart, and we went back to do some configuration, if I'm not mistaken, right? We did some configuration, like how do you configure your chart? What are some of them that we did? Hello, can anyone hear me?
We can hear you, sir.
Yes, for those of us that were in class, we did some customization, right? So we spoke about a couple of things. You can tell me some of them.
How to add title of the graph.
Yes, that's one.
How to add the X label and Y label.
What is X label? What is Y label?
X label is the horizontal label for the graph, and Y label is the vertical label for the graph.
Yes, that's labeling the X and Y axis. So we did a couple of those things, right? We did how you can change the fixed size and the resolution, like right. We spoke about that. We spoke about the labels and the titles. We spoke about how you can add legends to your chart. Do you understand? We spoke about how you can change the color, the style, and the marker of your chart, right? And we spoke about how you can have axis limits and ticks. Now today we want to go to advanced plots. So and one of the charts that they consider as advanced is the pie chart. So I don't know if you've ever seen a pie chart before, but let me just to share my screen so that you can see the notes that I'm using. Yes, this is a pie chart. This is what a pie chart looks like. Now, pie charts are ideal for displaying proportion and percentages of different categories. Like, say for instance, now you you want to say, okay, in this class now, we have both genders represented. Now you want to use you want to use a pie chart to display like the proportion of men or male to female. Do you get what I'm trying to say? Or say for instance now you are the type that you prepare a budget. They want to now use a chart to represent how much you spend on each category. Figure I'm trying to like, okay, how much do I spend on my rent? How much do I spend on utilities? How much do I spend on feeding? How much do I spend on transportation? How much do I spend on miscellaneous? Or how much do I spend on my wants? Do you get what I'm trying to say? So you want to use pie chart to represent it. Now, there's a rule of thumb about pie chart. I'm sure that we've spoken about. Have we spoken about pie charts before? Like during Excel, did we talk about some like the types of charts?
Yes, sir.
Yes, sir.
Okay, good.
Yes, sir,
Then
we did.
let's have a tutorial. The interesting thing about pie charts is that, or the rule of thumb about pie charts is, please don't use it to visualize anything that is more than 4 or 5 categories. The maximum should be 5 categories. Once you have more than 5 categories, don't use pie charts. What I mean is that, say for instance, now you want to visualize the money you spend on rent, you want to visualize the money you spend on feeding, the money you spend on utilities, the money you spend on transportation, the money you spend on your wants. Do you understand? Like the moment is more than five, don't use it again. Don't use pie chart again. You can go and use a bar chart to visualize it. So that one will show you like that one will show you in terms of height how much you spend. But because the thing is, if you have too many categories in your pie chart, you're going to get clumsy. And the last thing you want to do is have a clumsy chart that nobody will be able to read. Do you get what I'm trying to say? When you have like a very, very small amount of categories, like 3, 4, you're good. In fact, if you use pie chart, if you use bar chart for 3, 4, might not really, really represent it well. So please just use pie chart. Then how do we go about using a pie chart? So obviously, we have to import our Matplotlib, import our data in this case. Do you get what I'm trying to say? So now what you want to do is that you want to do plt.py. That's the what's it called for that one. Then look at it inside it. Forget about this autopcity for now. But inside it, you need two things. The first thing is you need the sizes, which is more like what is going to be the proportion. You get what I'm trying to say? And you need the labels. The labels are what you are going to give it, like this A, B, C, D. Then the sizes or the proportion are this 40, 26, 13, 20. Does that make sense? This autopacity is just that what ranges of color should I give to it? Does that make sense? Like to give it the color. Then you do your title, then you do your show. So let's come to our data and do something. Yeah, let's do for gender, because we really have 3 types of gender. We have the male, we have the female, and we have the elder. Right, let me show you dataset.ed. Dataset gender dot value count. Can you see? So we have male, we have female, we have order, and we have female. So this is what we want to use. Now, let's come here. From this, can you hear me?
Yes,
Yes,
sir,
sir.
we can.
Yes, from this now, like the approach we are going to use to create the pie chart is quite similar to this. It's just that we are going to change just a single thing. Now, we can just look at this and try to make an attempt on how we can do it. Look at this one that we did, this bar chart that we did.
So we need to change the can to pi.
Okay. So now let's write the code. So how are we going to write the code? So the first thing we do is that we say we can turn this to category count also. We can say right? Category count equals to data set gender dot value count, right? Now, we want to change this to I. Can you see how it works? Let's reduce the size. Okay, the DPI change it to 100. Yep. Can you see? This is how it works. You just change it to pi, and now you have a pie chart. Is there anyone that does not understand, except for those that did not come to class last week? Okay, those that did not come to class last week, do you understand?
No.
No,
No, sir.
no,
Not
sir.
at all. Not at all.
Okay, so that's what happens when you miss classes. Now, what we are trying to do is we are trying to plot a pie chart, and now we want to plot a pie chart for the what is it called, for a particular column, right? So we need both the we need the value count, because for you to plot a chart, you basically need two things. Like I said, you need the proportion and you need the labels, right? Now, for the that's why we decide to use value count. If you look at this category count now, this using value count brings us to this, because it gives us this as the label, this male, other, and female, and gives us 344, 328, and 328 as the proportion. Does that make sense? So that's what we are now plotting. Yeah, that's why we said this one is just this first part is to say PLT the fig size, that is how big should it be? 5 by 5. That is, just put it in a box, like in a square box of 5 by 5. Then the DPI, that's the resolution, should be 100. If you increase this, it's going to get bigger. If you decrease it, it might get smaller or be less visible. Then the next one is going to be now the category count, which is the one we created here. This category count that we created here, dot plot, that is, plot it. Then what kind of plot are we using? Pie chart. If you want to use bar now, just say bar. You see, it turns into a bar chart. If you want to use an horizontal bar chart, to say by age, then turns it to horizontal bar chart. Does that make sense? Please,
Yes, I do.
those of us that were not in class last week, when I share the resources for Matplotlib, please pay attention to it a lot, because you really missed last week. Because today we are going to finish it. Just like you guys are just coming like in halfway. So that's pie chart. Now the next one we have is a box. We call it box and whisker plot. I'm sure that you most likely would have come across it in your statistics too. Honestly, pay attention to that statistics. You see that I keep mentioning it. It's really going to help you. Because look at this now. If you cannot interpret this, then plotting it is not necessary, because why are you plotting where you cannot interpret? Now, a box plots are useful for visualizing distribution of numerical data. That is, we only use it to visualize numerical data through the quartiles, across the quartiles of that data. Now, I'm going to give you a quick overview. When we do box plot, what are we looking for? When we do box plot, we are looking at the spread of the data, and majorly we are looking if there is anything like an outlier. We are trying to get if there is an outlier in our data set, especially in that particular column. So that's what we are looking for. Now, look at this box plot now. This box plot now. It has more like 1, 2, 3, 4, 5. It has like 5 points that are very, very important. Now let me use this one. Every box plot will have 5. This is why they call it box, this box. Then this line is what we call whisker. That's why they call it box and whisker plots. And some people call it box plots. It doesn't matter. It's the same thing. The box in the middle here, can you see my cursor? That's what this box is. That's why they call it box. And these lines, this is the whisker of that plot. Then can you see these dots here? This and these dots. That's what we call an outlier. Now let me explain this chart to you. This that you're looking at here is the minimum. You see that when we do dot describe, we get the minimum. Do you get what I'm trying to say? This is the first quarter, which is like 25th percentile. Honestly, if to say you've covered your statistics, we will not have to go through all of this stress again. This is the quarter. Like if you divide your data into 4, this is more like if you decide to arrange your data and you divide it into 4, this is more like what you're going to get at as the 25th. What's it called? Like this is your 1/4. Then this thing that looks like maybe pink or yellow, this is what we call the median. This is the 50th percentile or the second quartile. And this is the third quartile. And this is the maximum. Now, how do we get this one and this
So I
one?
can't see your cursor.
You can't see my cursor here and here. Like I said, this is your, what is it called? This is your minimum. This is your first quarter. This is your second quarter, which is also as the same as median. This is your third quarter, and this is your maximum. Now, do you understand what I'm trying to say? Now, how do we get this? How do we get this the measurement for these two lines? Then anything here outside this is an outlier. Anything that falls outside this is an outlier. Now, how do we get this?
So I can't still see your cursor.
Most likely is your network. Or is she the only one?
Yeah, no, sir, we can't see
Same
your
here,
cursor.
sir. I can't
No, it's
see
not
it.
the only one.
That means it's my network. Wow. Can you see my screen?
Yes, we can see your screen.
Yes, sir. We can see your
Yes, sir.
screen.
Can you see the box plots?
Yes, we can see the box.
Yes, sir.
Can you see the part the label the one the label 3?
3.
Yes, three.
Yes, under
3, 2, 1. Okay.
yeah, 3, 2, 1. Can you see that 3 now? For that 3 now, we
Yes,
we have a big box and whisker plot, like the largest one.
yes, we can see.
Can you see dots like on top of that 3?
On top of three, yes. Yes.
Yes, that dot signifies or represents an outlier.
Yes.
Good. Then this, can you see that small line, just like cutting it off? That horizontal line cutting it off on top of that 0, on top of that dot.
Yes.
That's
Yes,
what
sir,
we
we can
mean
see.
by the minimum number. That's the minimum. Then this one, the beginning of this box, the beginning of the box is what we call the first quarter. That yellow is what we call the second quarter, which is the same thing as the median. The third line, which is the end of the box, is what we call the third quarter. And this one that we have here is what we call the maximum. Let's come here. Sorry, I'm trying to move to images. Yep. Can you see this? Can you see the one I highlighted?
Yes, sir.
Yes, this
Yes, sir,
part,
we can see it.
this is the minimum. This is the
Okay.
lower quarter, which is the Q1. This is the second quarter, which is median and Q2. And this is the upper quarter, which is Q3. And this is the maximum. I said
Maximum.
this place is the box.
Mhm.
And this is the whisker. This was the code I used to extend is the whisker. Do you understand it now?
Yes, sir, we do.
Now, how do we determine when something falls outside the scope that it's an outlier? Those of us that have covered the chapter on box and whisker plots, help us. How do we calculate? How do we determine if this? We said this is the minimum, this is the maximum. How do we determine the ones that fall outside the? How do we determine this minimum and maximum?
The minimum, the
Because
minimum is
I feel
the
like I
first,
feel like I feel like the minimum. This should not be the minimum. We
is the
in
first number.
real sense, can you hear me? In real sense, we call it lower bound, and we call this one upper bound because if we say minimum and maximum, minimum is the smallest number in your column, but that means that and the maximum is the highest number in your column. Now that means that if you have maximum, meaning that it's still supposed to be fall within your data set because it's supposed to be the maximum. But we call this one, this minimum, we call it lower bound, and we call this maximum, we call it upper bound. Now, there's a okay, look at this one now. Okay, this one already has the answer set. I want to ask you for. Now, this one, this is the lower bound, this is the upper bound. Can you see these points now? They are outliers. These 2 points, they are outliers. Now, how we determine the minimum? You know how we determine Q1 is 25th percentile, Q3 is the 75th percentile. You can go back to check it. And from year to year is Q3 minus Q1, which we call interquartile range. That's Q3 minus Q1. Now, to find these two lines, what we normally do is for the minimum, what we do is we say Q1, which is this, minus 1.5 of interquartile range, which is the difference between this and this. I don't know if that makes sense. Good. Then coming to the other side, you do Q3 minus 1.5 times interquartile range. So the only difference is that for minimum you use Q1, for maximum you use Q3. There's a mistake here because this is supposed to be plus. They made a mistake here. This is supposed to be plus. It's supposed to be Q3 plus 1.5 times IQR. Please pay attention. These guys to make mistake. This one is correct, but this one is supposed to be plus, not minus. Does that make sense? Can we go back?
Yes, I do.
Yes, so that's how we create a box plot. And if you want to create a box plot, you use PLT does box plot and you put the data inside. So let's try it with our own data and create our own box plot. So now let's use H. You might not have any outlier, but let's use H to plot our what's it called? Our box plot. So what do? We say PLT dot box plot. What's going to be in this bracket? Data set Why is it not showing anything? Let me see why it's not showing anything. Why is it not showing anything? Let's try another column. There's numeric. Let's use price. Why are they all not showing anything? So why is it not showing anything? I don't think it should be the color because this one too, I didn't change the color and it worked. And I think I changed it back. And it's not even calibrating it well. Let me see what could be wrong. Do we have missing value? Let me see if we have missing value. Dots. Data set dots is NA dot sum age. Oh, it's because you have missing value. So let's drop the missing value. Data sets dots. Let's just drop them because drop NA in place. So you see what having missing value can do to your data. That's why it's important to
Yes,
clean.
sir.
You just be looking like this code is correct. Now, how come it's not? Because I honestly, at first, I could not even think of what to do because this is not my first time plotting box plots. So why is it not now showing? So it was just like my mind just said, okay, check if you have missing values. and that's it. So that's how you create a box plot. You can label it using plt.label both the x-axis and y-axis. You can have a title. You can even decide to change the color if you feel like. You can change the fixed size and every other thing that you need. So let's move on to the next one. This one is its map. Have you heard of its map before?
Yes, sir.
What do-
Yes, sir.
what does it show?
The dominant part.
It shows it shows everything, both the dominant and the non-dominant. We use it to show correlation. When we say correlation, we are basically saying how does one when we say correlation, like when people say what's the correlation between what I'm saying and what you're saying, that is what's the sync between what I'm saying and what you're saying. Do you get what I'm trying to say? So we do it in data sets. Correlation means that to what extent does a change in one data set affect the change in the other data set? Let me give you an instance now. Height and age. To what extent does your height change when you grow older? Does that make sense?
Yes, sir.
So that's what we mean by correlation. So if you want to plot like a chart that shows that, so we use its map to show it, and basically it works only for numerical column. It only works for numerical column. So you can use IM show to do that. So now look at it. Like IM show, you pass in your data, which is the entire data set. Then you pass in your CMAP is alt. That is, you use it to display. When you say alt, you use it to display like look at this now. Those that are close to zero, they are very, very dark. Like it's just basically like in a shade of red. You see, these ones are white, like the ones that are close to one, they are white. Those ones that are close to zero, they are very black. Then there's now contraction as it goes on. So that's what we normally use CMA for. Then we have the interpolation too, which is the nearest. Then you can say PLT dot coolbar. This is the coolbar. So that you can use it to show the like you can use it as it's more like like a legend for each map. So let's try with our data sets too. Let's try with our data sets. So we say plt dot im show. What are the three things that we need to put inside it? The first one is our data set, right? Comma cmap equals to what? In interpolation equals to nearest inclusive bracket. Why is this still not showing? Main data of object cannot converted to float. So let's just say df dot sorry data set dot drop any in place equals to true. Now I told you that this only works in numerical column. Do you get? So we need to only select the numerical column to do that. So how do we do that? How do we select only the numerical columns? We say numerical columns equals to. Now, which ones are the numerical column? But before we can do that, let's do dataset dot info. So these are all the columns. How many of them are numeric? 11 of them are numeric. Both float and integer are numeric. So now how do we go about it? So what I will just do is I would say numerical column since nobody is responding. I would say dataset, right? Dot select underscore d types. This is not beginner. There is a way I can do it that is beginner friendly, but I just want to get it done. Then I'll just say d types. Then inside the bracket, I would say include equals to. Now you put a list of the ones what you want to look for. I will say number, then close it. Okay, I didn't close it. I didn't close this. So now I've selected numerical columns. So now I can use the numerical columns here. Can you see? So now now is showing all we need to do is to design our table. Like sorry, to make sure that it comes out well. Now can tell me how we can improve this. Don't make me the only person speaking. Just think. Because trust me, sometimes some of these errors too, I just quickly think about them. Okay. For the problem we have here is like it's a single one. Now the problem is that the IM show works only for 2D, right? But our this thing is only showing for 3D. Sorry. Now, what we can do is that instead of using IM show, we can use what we call its map to do it. Then its map is not like the equivalent of its map in Matplotlib is the IM show because its map is actually a Seaborn function. How do I put it now? It comes with Seaborn. Matplotlib does not come. It comes with IM show, right? And it has quite a lot of limitations. This IM show has quite a lot of limitation. So there are ways we can do it. The first one is we can try to normalize this our data. There's something called normalization. When we say normalizing our data, we are basically trying to say, let me give you an instance so that you get what I'm trying to say. Think of revenue and the age. Can you see that like age can only be maybe from maybe 1 to 120. But revenue, in fact, let's do the data set so that you can see what I'm saying. We'll come back to fix the issue. Data set dot. So let's put age and revenue, comma, revenue inside the bracket. Can you see that? Like, can you see the gap? 56 to 38,000, 381,000. Now, let's say dot describe so that we can check the values. Now, see the mean of this one, see the mean of this one. Can you see how far they are? So what we normally do when we try to normalize is that we force all of them to be in the same range without losing the number. So what we can do here is that we can force all of them to be within 0 to 1. So that's what we mean by normalization. In such a way that all of them will be within the same range. Or we can decide to use Seaborn and just use correlation. So before I come to this, let's use Seaborn. So we can say correlation matrix equals to our numerical column dot core. So if you print this correlation matrix now, you see it's a table. Can you see it's a table that is showing us what we have, like of our numerical columns, like how they affect each other. So this is what we want to plot. So now we say import Seaborn. Seaborn is also a library like that does the same thing as what's it called? As Matplotlib, as SNS. So you can now say SNS dot itmap. So like it's just like plt dot im show. This one is SNS dot itmap. Now we're going to put our correlation matrix that we did here. This one. We'll put it inside this bracket. Then comma. We say annote, like a note that is annotated equals to true. Can annotate it. Then you can say CMAP. You can decide to make it hot or cool warm. But let's use cool warm. Yeah. Warm. Yep. Then plt.show. There's something I'm missing. plt.show. It said position argument follows keyword argument. How is that a problem? Sorry, CMAP equals cool warm. Yes, can you see? Now we've been able to create it. So you can say you can increase the fig size so that it does not get clumsy, right? And your DPI. So let me just copy from what we've done earlier. So that it does not get clumsy. Okay, let's use 10 by 10. Oh, yeah, 10 by 10. Yes, can you see? Now it looks okay. Does that make sense? Can anyone hear me? Are you guys still with me?
Yes, I will with you.
Do you understand?
Yes, sir.
Okay, so let's move on to the next one. Ignore 3D plots. Nobody plots 3D plots. Now, let's cover some visualization tips, right? Now, choose the right plot. It's important that you choose the right plot when you want to make your plot, right? When you're supposed to use pie charts, use pie charts. Don't use its map when you're supposed to use pie chart, or don't use pie charts when you're supposed to use bar chart. Use like consider the nature of your data and the information that you want to convey when selecting the appropriate plot type. Different plots are suitable for what for different types and what different data types and objectives. Now, use color effectively. Choose colors that are visually appealing, easy to distinguish, and accessible to colorblind individuals. Matplotlib offers a wide range of color palettes for you to choose from. The next one is please handle missing data. Can you see what happened when we didn't handle our missing data? Consider how missing data should be handled in your data. You can choose to exclude missing data or display them in a specific way, such as using markers or different color. Now, adding annotation and text. Annotation and text can provide additional context and insight to your data, meaning that please like label your data. This is what I'm trying to say. You see now, I said annotate equals to true. Let me change this to false. Can you see? It's just going to show like what we have there. Just show you the color. Please try to always annotate your data. It's going to help you. It's going to help you or your audience to understand what you're trying to what you're trying to convey to them. Yes, please annotate your data. Not only this one, try to annotate all of your what's it called? All of your charts such that people can understand. Please, another mistake that people do is they over annotate. Don't over annotate and make sure that when you're annotating, you annotate in the right place. Sometimes you annotate with legend. You annotate with legend. Just make sure that you try and annotate. And please put text in your data, meaning that put your x axis, your y axis, give it a title. Every text that requires that you need to put, please put them. Then, how do you save a plot? Because when you want to present it, you will not present your Jupyter notebook, right? You want to most likely put it in a PDF. Sorry, put it in a PowerPoint presentation, and if you screenshot, you're going to reduce the quality. So how do you save it? You can save plot to file, and you can save in a different format. You can save as a PNG file, and you can decide to save as a PDF. Now, this is how you save plt.savefig. Then you need the name dot the format that you want. This one is PDF. Now let's try it on some of the charts that we created. So here I can come here and say plt dot save pig, right? And I can say correlation, or I should say its map dot png. Now it has saved. I can go to my downloads or wherever it is that I have this and look for it. Can you see this is it? I've downloaded it as a PNG file. Give you a moment, it's still loading. Why is it taking time? Or let's just look at it from here. I don't know why it didn't save properly, but let's try it again. It didn't save properly. Let's try to save another one. Let's save this one. Maybe because I did the chatting. Okay. This is the box plot now. Let me look at why it's not displaying. Why is it not displaying them? Sorry, it's because of the way I arranged it. Like the save is supposed to come before the before the show. This is how you're supposed to arrange them. Save it, then dot show. So let's come back to this one too, so that I can show something for you. Does that make sense?
Yes, sir.
So now if you come back and look at this map now, she's going to show you your map. Beautiful. Yep. So that's what I can remember to that's what I can cover under what's it called? That's what I can cover under Matplotlib. These are just some real world examples. Look at this. Time series data is common type of encounter in data science. Matplotlib allows you to visualize it. It's just basically things we've covered so far. So I'm going to add the note for you. And this is geospatial data visualization that I was talking about geopandas. Yeah, you see, they imported geopandas. This is plotting a map. Maybe sometimes you work with in oil and gas and you want to plot where your oil rigs are. So you can use geopandas to plot them. So anything. So look at this now. This is the Matplotlib video that I'll be going through. It's also like it's also in 10 what's it called? 10 parts. So just go through them. You see, it's going to cover them one by one. Like how do you create and customize your charts? Like we cover that. Like bar charts and analyzing. We covered bar charts. This is pie charts. This is stack plots, filling areas of line plots, histograms, scatter plots, time series data is a line plot. So plots. So they are like it's going to really just cover again everything we've covered and maybe some more examples for you guys. So please try to go through
So we
them.
can't see the video. I'm seeing geospatial data visualization.
Oh, sorry. So this is the video I'm talking about, like just the like this thing. So the first one is how to create and customize your first plot. Like then the second one is talking about bar charts, then pie chart, then stack plots, then line plots, then histograms. They are basically then scatter plots. They are basically things that we covered, and even things that we covered that I did not cover. Like we covered like box plot. I'm not sure I covered box plot, but then I think this is going to be a good head start for you when it comes to it. And for those of us, so let me share the link with you now. See, somebody should take this and put it on the class page. Yes, this is it. Somebody should do it and put it on the class page. Let me create a sheet for this too and share with you guys. So this is the one for the Matplotlib. You know what to do. Once I share the link, create your own. Go with the link. Create a sheet for yourself and follow our usual approach. So you're expected to finish this between now and next weekend. So please, somebody should take this too and put on the class page for me. So is there any other? Do you have any question? But other than that, that's the end of our journey together with Python and Matplotlib and the likes.
So you said we should open a sheet or something.
Yes, this
I
sheet.
didn't get that part.
You can watch the video that Zainab shared on the platform. You understand what like I took my time
Okay.
to explain it
Okay.
last week how you're going to do
Okay,
it.
sir.
So is there any more question? So if there is no question, I'm going to share your pandas and Matplotlib assignment with you. When is the Python assignment due? I think it's due next week. That's 7th.
No, sir, 2 weeks time. You gave us 3 weeks.
Okay, no problem. It's due 15th. So I'm going to when that one is done, I'm going to drop this this assignment so that I don't get overwhelmed, like the one for this. So
So the Python assignment, you mean the project, Abby?
yes, that's the Python project.
Okay. Okay.
All right. Is there any question?
No question, sir.